Alright, in this video we'll be looking at section 627, that's page 327 and 328. The assignment is 6.74, omit C, and 6.77. We did 6.74 in class. I'm going to now do number 6.81. This is not in the assignment, but it will help with some that are. .81. This is at the top of page 328. Okay. It says that the LA Times reported 80% of passengers like to do most online what they like to do most on online Problem 6.81 says the Los Angeles Times reports that a favorite thing for flyers of long flights is to either sleep or rest, 80% of them. Suppose that the actual percentage is exactly 80% and consider randomly selecting 6 passengers. Alright, so this situation is binomial. Okay, we learned about 4 characteristics of our binomial. Number 1, it's a fixed number of trials. Fixed number of trials. Okay, in this case there are 6 trials. We're going to ask 6 passengers. Number 2, 2 outcomes. Success or fail in this case, the thing they like to do most is to sleep or rest, or not that. Okay. Only 2 outcomes to the situation. 3, the probability of our success is constant. In this case, the probability of our success is 0.8. That's the chance of the person preferring sleeping or resting. And lastly, the trials are independent. We can safely assume that when we ask the first person about their preference, it's going to have no influence or offer us no information about the next person. So this situation is binomial. And we learned a formula for finding these binomial probabilities in class. It was a little crazy looking, but it really wasn't too bad. Okay, the probability that x is of some particular value was going to be n factorial divided by x factorial times n minus x factorial, all times the probability of success to the power x times 1 minus the probability of success to the power of n minus x. Alright. In our case, n is the number of trials, 6. P, the probability of success, is 0.8. This x is however many successes we're going to be seeking in the particular problem. So, in A part, it says calculate for and interpret that probability. We're looking for the probability that this value x is 4. Alright, the probability that x is 4. So n is 6, 6 factorial, over x is 4 factorial. N minus x, this is 6 minus 4, that's 2 factorial, times the probability of success, that's 0.8, times x, that to the x power, I mean to say, is 4. This is 1 minus the probability of success. If we have a 0.8 chance of success, we have a 0.2 chance of failing. N minus x, this is 6 minus 4, or 2. Alright, looking at this portion of the calculation, it's simply the it's the probability of success to the power, that is, how many we want. the probability of a failure times the rest. These two numbers will always sum to our n. 4 and 2 sum to 6 or n. Well, this here is often called the binomial coefficient. It's simply a way of finding how many ways we can rewrite this scenario of 4 successes and 2 failures. All right. Little calculator work here. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 2 factorial is 2 times 1. Well, you see this cancels with this. 2 divides 6, leaving 3. So what we're left with is 5 times 3. There are 15 ways to write this scenario. Times 0.8 to the 4th and 0.2 quantity squared. This is approximately 0.246, which is 24.6%. So they ask us to interpret this probability. Well, if 80% of people prefer to sleep or rest on long flights, then we have an approximately 24.6% chance of getting exactly 4 of the next 6 people. To prefer sleeping or resting. Okay. Recall the command on Excel. On Excel, you can hit equals binom.dist, and then it calls for 4 entries. The first, I'm going to show on Excel now. Equals binom.dist. Clicking on that, you will see it prompts for number S. That is our number of successes. In this case, we wanted 4 successes. Then it's the number of trials. Then it's the probability of success. And then lastly, it says cumulative. Here it's asking, do we want a cumulative probability or a single value? We want a single value. This last is going to be a 0. So number of successes, 4. Number of trials, 6. Probability of success, 0.8. And this last is a Boolean operator. It's just a yes or no, and we're saying no to the cumulative. I hit enter, and there's my value, 0.24576. All right. So to do this calculation in Excel, it's binomial distribution, X is our number of successes, N is the number of trials, P is the probability of success, and this last thing we're going to enter in 0. 0 for a single observation, or 1 for cumulative if we want all values less than that. Alright. Next problem, it says calculate P of 6, the probability that all 6 prefer to sleep or rest. Well, we can do the same situation. Binomial dist. This time 6 out of 6. Probability of success 0.8. And again 0. If you do this, it's going to return .262. Okay, this is the probability that X is 6. That is, every person prefers to sleep. This is also the same as 0.6 to the 0.8, pardon me, 0.8 to the 6th power. Okay. Lastly, it says calculate the probability that X is greater than 4. Previously, when we were doing the continuous situation, we said there's no difference between the greater than, equal to, or strictly greater than. But there will be in this discrete case. To say greater than or equal to 4 is the same as saying probability that it's going to be exactly 4, probability it's going to be exactly 5, probability is going to be exactly 6. All these scenarios would be that. Well, we've already calculated 4 and 6. Now we just need to calculate 5. The probability for 4 was 0.246. We don't yet know the probability of 5. The probability of 6, we calculated that. That was 0.262. So we only are left with this probability that we get precisely 5. Well, going back to our Excel spreadsheet, we're going to do our binomial distribution. This time we're going to seek specifically 5. Alright, and 5 exactly we see is 0.393. Okay, so the probability that we have 5 is 0.393. So we have 0.246 plus 0.393 plus 0.262. Summing these. That sums to 0.901. Alright, that's the probability of getting greater than or equal to 4. I'm going to show one additional way that we could find this. To find the probability that X is greater than or equal to 4, I would simply find the probability that X was 3 or less than and subtract. That is, I could say it's 1 minus the probability that X is less than or equal to 3. If I am greater than or equal to 4, that means I am 4, 5, or 6. What it means is I am not 3, 2, and 1, and that's what this is saying. 1 minus the probability that X is less than 3. Well, I've changed it to this because Excel or a calculator will find us this situation. Now, we're going to go back to our binomial distribution. Binomial, D-I-S-T, and we're going to come with our number of successes, in this case 3, still 6 total trials, still probability of success is 0.8, but this last one is a Boolean operator. Boolean operator that's simply asking us to enter a 0 or a 1 if we want a cumulative. Now we want a cumulative. So before we entered a 0 for a single value, now we're entering 1, and it's going to find us 3, 2, 1, and 0. Alright, here we go. back to Excel. I have my binomial distribution. I'm going to select 3, but I'm going to change this 0 for a single value to 1, and you can see the final selection is cumulative, and we are saying we do want a cumulative. We hit enter. This result is 0.0988. So we still have our 1, but this factor here was 0.0988. If we subtract 1 minus 0.0988, you're going to see 1 subtract 0.0988. That is 0.901. And indeed, this was the same as this. Okay? So it was, had we not already had those other two values, it would have been much quicker to find this strictly less than. All right, with that information, you should be able to answer the rest of those problems.